The tweel structure itself is relatively simple. We have rubber compounds in the tread band, as well as some cable reinforcement. Then we have a polyurethane compound for the spokes, and then we have an aluminum wheel. But then once it's all made, it really is one single component. It's one mounted assembly. And you can compare this to the current pneumatic tire, in which we have basically 5 components. First you have the tire, then you have the wheel, you have to have air, you have a valve, and now we're adding a pressure monitor. So basically what we've invented here is one mounted assembly, which is one component that replaces 5 components. With the new invention, we don't have to worry about air inflation pressure. We don't have to worry about retention, bead unseating. That gives us a great deal more design freedom. We can have a flexible wheel. We have complete technical control between everything that's between the axle and the ground.
Owners of skid steer loaders lose productivity daily due to flat tires. Tweels will eliminate this problem because of their damage tolerance, while providing the compliance, comfort, and mobility of pneumatic tires. And they'll do that without weighing as much as the equivalent solid tires often used in these applications.
They can also, it turns out, give better wear life, better comfort, and machines can actually work faster. Today we're on the second loop of field testing with tweels with real customers, and we've tested them in the U.S., in France, in Italy, in the Netherlands. So after the first loop, we fixed the problems that the customers found with the tweels, and we're running a second loop to see what new problems they might find.
The U.S. military has recently begun organizing new combat formations that make extensive use of wheeled vehicles. The key characteristic of tweels in military applications is their lack of a single-point failure mode. Tweels can suffer multiple penetrations from bullets or artillery fragments and can continue to provide adequate mobility. Perhaps the most surprising capability of tweels is their ability to survive and continue to work despite being exposed to direct blast effects. When exposed to the 250-gram TNT equivalent of the largest anti-personnel mines, tweels continued to work. And when they were doing that, they also directed the blast energy of the landmine away from the vehicle, unlike other solutions where the blast energy comes up through the tire and is deposited into the vehicle and its occupants. Military vehicles using our tweel technology will be more effective, less costly, and more capable of completing their missions than any other solution available on the marketplace today.
In order to better understand the future blacking points, we've gone ahead now to take a look at how the tweel would do on today's Audi A4.
The Audi application for tweels is really a stretch application. All our applications to this point have been slow-speed, low-speed applications, but the Audi, of course, is a high-speed application, very demanding automotive application. So one of our objectives was to see if we could reach the mass and rolling resistance levels of a pneumatic tire. And these tweels are within about 5% of the pneumatic tire levels, which is pretty impressive.